In this video, we're going to see how to solve the most difficult trigonometric equations. And these are going to be when you have a trig function of a multiple angle, 4x, 3x, 2x down here. So we're going to learn how to handle those things because they do require a little bit of extra care compared to other trig equations we've been solving. So if we look at this, the first problem here, find all degree solutions that are between, so all degree solutions at all, no matter one rotation or more, to the equation sine 4x equals square root of 3 over 2. Well, first things first, let's look at our unit circle. Let's see where the y value is root 3 over 2. And we're talking about degrees. It's going to be up here at 60 degrees. And the y value will also be root 3 over 2 at 120 degrees. So your two angles are going to be 60 degrees and they're going to be 120 degrees. But they did ask us for all degree solutions, so we're going to add 360k here to each one of these, just like we did in the earlier video. But there's a problem that it's not x equals here because it wasn't sine x, it's sine of 4x, so it's 4x equals each of these things. And then once we have 4x equal to each of these things, then we divide by 4, and 60 divided by 4 is 15, but you also have to do 360k divided by 4 is 90 degrees k, and over here 120 over 4 is 30, and 360k is also 90k, and so your full answers is 15 plus 90 degrees k, and 30 degrees plus 90 degrees k. Notice how it's not 360k in our final answer like it has been in the past, and that's because of the multiple angle inside the trig function. So think about going back to the graphs that we had before, and we had period and things like this, and frequency, and so these things are being changed by this, and that's why we end up getting plus 90 degrees k here instead of the previous plus 360 degree k. Okay, so that's one thing. Next thing up is we're going to solve degree solutions to tangent 3x equal to 1, but this time we want 0 to 360k. Okay, we know for tangent being 1, that's either at 45 degrees or at 225 degrees. That's where tangent is 1. So you might say 3x is 45 degrees, or you might say 3x is 225 degrees, and we get 15 degrees. And let's see, 3 into here would be 75 degrees. And you might say those are our two answers. And it would make sense because there was only two answers in the unit circle. But once again, this is not going to be quite right because by changing the x to 3x, it means we're going around 3 times as fast. So going around one circle, 0 to 360, really means going around it 3 times. So this is not actually going to be the right final answer. What you want to do instead is pretend that you're finding all solutions, add up your 360k's here, and then after you add your 360k's, divide by 3, it's 120k, 75 degrees plus 120k. Once you have these down, then ask yourself for different values of k, when will you get an answer that's between 0 and 360? So for this first one, if I start out, k is 0, I get 15. If I do k is 1, I get 135. If I do k is 2, I get 255. And if I did k is 3, I'd be beyond 360 degrees, so it's not valid. Then continuing on over here, if I put k is 0, I get 75. put k as 1, I get 195. If I put k is 2, I get 315 degrees. And if I put k as 3, once again, I'm beyond 360. And so you get all of these answers here. And it's a very easy thing to overlook on a problem like this. So if you ever have a multiple angle, 3x, 4x, whatever, and you have a specific range, 0 to 360, it's going to be very tricky to make sure you get all of the possible answers. One thing that can help you is, again, since this is 3x inside, that means we're going to travel around the circle 3 times for every one rotation 0 to 360, because it's going 3 times as fast. And every time it goes around, it picks up 2 solutions. So picks up 2 solutions, picks up 2 solutions, picks up the last 2 solutions, and that's why we have 6 different solutions in the problem. Just be very careful on questions like this because they're one of the most often missed problems in this class. Last one, we're asked for radian solutions. We're asked for radian solutions between 0 and 2 pi, and we're going to have to approximate. So this is going to be a whole bunch of stuff all at once. Let's be careful here. So cosine 2x is 0.3. Let's see here. That's not a special angle, but cosine is positive. It's going to be happening somewhere in quadrant 1 and somewhere in quadrant 4. We know that has to be true because that's where cosine is positive. We're going to put our calculators on the radian mode, and then we're going to do cosine inverse of 0.3. This will give us the reference angle, and I get 1.3 radians. And if that's 1.3 radians, then if we get the other one here, it would be 2 pi minus that. So I'd have 2x is either equal to 1.3 radians, or 2x is equal to 2 pi minus 1.3 radians, which if I put that in my calculator, I'm getting 5.0. But again, we add on our 2 pi k to each one of these. We go ahead and divide both sides by 2. That'll be 0.7. Again, we're rounding the nearest tenth. So 0.65 rounds to 0.7. And then divide by 2, we get pi k. Divided by 2 over here, I get 2.5 plus pi k. And then we start plugging in values of k until we get too big. If I plug in k equals 0, I get 0.7. If I plug in k equal to 1, I'd have 0.7 plus pi, and that gets me 3.8 radians. If I were to plug in another pi there, it would be something that was too big. Just for argument here, 2 pi plus 0.7 would be a 7.0 radians, which is too big. That's why we don't include it. This other one, we plug in k equals 0, you get 2.5. And if I add pi here times 1, I get 5.6. 5.6 radians. And if I write another pi, I get too big, so don't include it. And so these 4 are the answers we are looking for on this equation. So again, when you're doing multiple angles, even if they don't ask you to find all solutions, you should pretend it's an all solutions problem. Add on your 360k or your 2 pi k. Then divide by whatever it takes for your all solutions to get back to the regular problem, which is x equals, get plus something else, again plus 90k plus 120k plus pi k. And then if they're asking you only for solutions in say 0 to 2 pi, then you start plugging in the values of k until you get outside of that range. So these again can be particularly tricky problems. Maybe watch this video a couple of times to really understand it and practice these a lot.